So I think while we're waiting for the last people to log on, I'll just give a short introduction and then I'll hand it over to Christian. So welcome to our last webinar before the summer break. We're kind of hitting the very last time slot before everybody starts to take off on vacation. But my name's David Fink. I'm a digital manager at Henning Larsen and the chairman of BIM Copenhagen here in Copenhagen. And if you don't know much about BIM Copenhagen, we're a volunteer group that tries to create events like this to find the latest in digital technologies within digitalization, BIM, and construction. And we're made up of a volunteer group where we try to find these events and put them together and bring this information to you. So let me see if I can get my screen to change here. So as part of the steering committee, we're a group of a wide variety of backgrounds from architecture, contracting, educational facilities, client management, and software developers. And if you have events like this that you would like to see in the future, or if you have something interesting to present, you can contact one of us in the steering committee and we'll try and put up an event around your topic. We also have a few sponsors that make these events possible. So if you're also interested in being a sponsor for BIM Copenhagen, let me know and we'll give you more information about how you can be a sponsor and the benefits of being a sponsor of BIM Copenhagen. So today's webinar will be recorded. And the way we will run this today is we have Jakob, who's sitting in the machine room. He'll be collecting your questions. And if there's a lot of the same questions, he'll interrupt. But otherwise, we'll take all of the questions at the end. This Urban Decarb project is something I've been following from the sidelines for a while, and it's really been growing and it's developing into a nice tool. So I think I'll hand it over to Christian now, and he can give you all the details and tell you all about it. So
great, thank you, David. I think I will just start by sharing my screen here and take over from you. And I guess you can all see my screen now. Okay, great.
That's perfect.
Perfect, nice. Yeah, so my name is Christian Oettinger. I'm a design engineer here at Henning Larsen in the R&D team here at Vesterbro in Copenhagen. And I've been here for roughly around 3 years, where this Urban Decarb tool has really been one of the things I have been working a lot on over the last couple of years. So thank you for joining this session, first of all, on the Urban Decarb tool. And I think I will dig into the details and all about Urban Decarb, but here in the beginning, I'll just give a very brief introduction to what Henning Larsen is, if you don't already know it from David. So Henning Larsen is an architecture, landscape, and urbanism studio. It's a global studio founded in 1959 by Henning Larsen. And it's global in the way that we have more than 30 countries where we have completed or ongoing projects. And then at the same time, as you can see with the green ones here, we also have offices all over the world. Then we're also part of the Ramboll Foundation, and that is important in this case with the Urban Decarb tool here, because that's really why we can even develop a tool like this. So first of all, to get the funding, the hours to develop the tool, but then second of all, also to harvest all of this information, all of this data, and all of this expertise from all the people within Ramboll when it comes to all different engineering services that you need to integrate into a tool like this one. Then in Henning Larsen, we have these 3 kind of like design topics, design KPIs. So first of all, design excellence, sustainability, and then technology and data. And as I'm sitting in the R&D and more on the engineer side, I will focus on these 2 here today about using sustainability as a design criteria, but then also how to measure our impact with technology and data. So here's a bit about like how we work and what we have developed in the R&D team over the last couple of years. So it's everything from tools that can run microclimate, energy design, generative design, noise simulation, daylight acoustics, etc. So we have this kind of like experience in developing tools or using already existing tools on projects here internally in Henning Larsen. And then the latest one of these is the Urban Decarb tool. So in very short, Urban Decarb is a tool for early stage informed carbon emission reductions in urban development. And I will try to keep this introduction on why we even built it in the first place kind of short, because I think kind of like why we're trying to create tools like this. So first of all, there's going to be a lot more people in cities in the future, 2.5 billion more compared to now in 2050. Then at the same time, the cities are responsible for a large part of all of our global carbon emissions and a large part of all of our natural resources. And that's why Antonio Guterres, he said, he's the Secretary General of UN, he said that cities are where the climate battle will largely be won or lost. So that's kind of like setting the scene for why we even started creating this Urban Decarb tool. Then there's also something about that there is actually starting to be a lot of regulations, LCA, carbon assessment, putting in limit values. And as some of you may know, last year, Denmark introduced LCA requirements and limit values into our building regulations. And actually a few weeks ago, they made them even more strict from next year on. And if we look at other countries, especially here in the Nordic, other countries are also starting to implement similar building regulations. The challenge or issue or problem with this, as you can say, is that when you work with an urban scale and you work with the urban fabric, of course, a lot of the urban scale in the cities consists of buildings. But in reality, there's also so much more that goes in between all of these buildings here. And as you can see on this photo here, it's everything from roads to landscape and green spaces. It's parking. It's a transformation of existing buildings, but also transformation of existing infrastructure. And that's just all the stuff of the city you can actually see. Then there's also, of course, you can also see the mobility of all of the behavior from cars and public transportation, and then below ground also utilities. So instead of only looking into LCA requirements for buildings, we're actually trying to kind of extend the scope and include more categories into the urban scale carbon assessment here with the tool. So that's the overall goal of Urban Decarb. It is to make carbon emission data available for informed choices in early stage urban design in order to minimize our environmental footprint of projects. And in order to do this, as it is, this Urban Decarb project has been a research project where we have kind of like tried to create a methodology, because there is not any common methodology for urban scale LCA as there are with buildings. We have kind of listed these research questions here. So the first one is, what are the most carbon intensive parts of urban areas? Because when you work on such a scale, it's really the law of the big numbers, trying to figure out what are the most intensive parts first, and then we focus on that, and then you kind of like include all the other stuff afterwards. Then it's about where we can actually find all of this data for the urban elements, because if you have ever worked with any kind of LCA assessments, it can really be tricky to find the data. So that has been one of the challenges with this project here. And then in the end, how can we actually use this to then design? So starting with the first question, what are the most carbon intensive parts of urban areas? So we looked into this global status report for buildings and construction by the United Nations, where they took all global carbon emissions and divided into these sectors here. So very overall, they divided into these three sectors, as you can see here. So 40% of all global carbon emissions comes from buildings and infrastructure. Then 22% comes from transportation mobility. And then there is this 38% from others. And if we dig a bit more into what it actually includes, then you can see for the buildings and infrastructure, it's both the embodied carbon emissions as well as the operational carbon emissions. And it's everything from all of the building materials, hardscape materials, landscape and green area materials for that, and then infrastructure materials. And then on the operational carbon, it's both the building energy, but also the public energy around. And then there are also the mobility carbon emissions coming from both the daily mobility where you drive around or take a train and use some fuel or electricity, and then also the actual vehicle manufacturing that's included in this category here. And then there is this whole others quite broad category, which includes both food and aviation and what clothes you're wearing, what TV you're buying, etc. And when we started out this project, we kind of tried to set our scope and figure out where we could really make a difference when we did these urban master plans. So we said that our sphere of influence as urban designers is really on this buildings and infrastructure part and on transportation, and that is then what is within the scope of the Urban Decarb tool and what we're somewhat already did and trying to really integrate within this tool. And then we took these two sectors here and divided into a few more categories, as you can see here. So first of all, the category which is called buildings, both on materials and energy, but then also the open spaces, everything from roads and sidewalks to parking and green spaces and parks. And then all the stuff below ground, all the networks that goes into, for example, all the buildings, including electricity and water and district heating. And then the category called mobility. And as you can see here, there are some of this we actually got quite far with already in our tool, which is already fully implemented within our Rhino Grasshopper workflow, which is all on the buildings or open spaces. Of course, it can always be more detailed, but we got quite far with this. And then we are working quite intensely on integrating networks and mobility in the tool, and already kind of like figured out a methodology, and now just trying to see how we can actually implement it. Then next question. So where can we find the carbon data? So if we look at the same categories as we saw before, when we prototyped this tool, we have been working specifically for Danish projects, and that's also where we have used the project or the tool the most on projects. So for the buildings, we have looked into Danish EPDs as well as the Økobau database, which is kind of like the standard in the Danish building regulations. And then for the open spaces, we have digged into this database called Info-LCA, which is made by Vejdirektoratet, which is the Danish road directory, where they created a database for LCA numbers for all different kind of infrastructure elements. And then we're also using this database called Climate Positive Design in order to figure out carbon sequestration rates for example, landscape and trees and stuff like that. And then if you look at networks, that's also something where we're looking into Info-LCA and kind of like use the same database here. And then for mobility, we are looking together with Ramboll's mobility department into various kind of transport survey data sets. For example, one which is made in Denmark specifically by the Technical University of Denmark. So that's overall where we get the data from, and I'll be a bit more specific on how it works a bit later. So then there's also the question about like how we actually estimate this urban carbon footprint, and we're using this methodology which is called bottom-up LCA. And essentially what bottom-up LCA means is that the sum of the carbon footprint of the urban area is the sum of all its elements and various parameters that goes into the urban area. The urban area here, it consists of some mobility, some networks, some open spaces, and some buildings. And then if we take buildings as the case, then all of the buildings consist of some operational energy, some construction emissions, some transportation, and then a bunch of products which we can find EPD and data sets on. And if we take all of this up, then we can actually find the total urban carbon footprint. So the total urban carbon footprint is the sum of the impact from each of its elements. And that also means that when you work with it here and you kind of like sit and you choose between different scenarios and different materials, the carbon footprint is actually directly determined by those design changes that you make. So for example, if you change a facade or you edit your window to door ratio or you make your building slightly taller, then it will directly influence the quantities and therefore also the total carbon emissions. And this is a sketch of this overall workflow for how we perform the LCA calculation. So there is first of all, a lot of quantity extraction, actually figure out all the quantities, and then we match that with a catalog of standard components. So starting with this quantity extraction, we're using a parametric workflow in Rhino Grasshopper, where you have often created these kind of like building massing, volume, urban models where you do your roads and landscape overall and buildings. And then we're running this simplified quantity extraction. So that means that there are some direct and indirect quantities. It's something like direct ones could be that you can directly find the area of the ground floor or the roof, and more indirect ones are, for example, that you can get the facade area and then input a window to wall ratio, and then you get your window area and you get the facade area. So that's more kind of like the simple quantity extractions that we're using this Grasshopper workflow that we created ourselves in order to estimate all of that from these building massings here. And then for the structure, which often in these cases can be quite difficult to estimate when you're so early, or even include in your calculation when you're this early on a project. So in this case here, we're using a tool which is created by Ramboll, Finland. It's called Phoenix. And essentially what it does, and I'll also show you later when I show the actual tool in action, is that it takes your building and splits it into floors. Then it runs this geometry and kind of like lays out the grid. And then it performs a structural analysis and size your structure depending on just very simple inputs such as your building massing and your a few details on your materials and typology loads and stuff like that, and then just runs through your all of your buildings and defines the structure, estimates the structure. Then we're also running an operational energy simulation, and we're running that with this tool called Dragonfly, which is part of the whole Ladybug tools, which is integrated into a lot of workflows in Grasshopper in general, and we're also utilizing that in our operational energy simulation. And of course, there are a few simplifications when you work on an urban scale like this, because if you have to run just a very simple energy simulation of one building, it can often be very time consuming and take like multiple hours. And in this case here, we actually want to get kind of immediate feedback, or at least as fast as possible. So what Dragonfly does is that it models all your buildings from 2D floors and then a floor to floor height. So you can also see on the buildings here that it cannot, for example, take into account steep roofs. It just finds like an average height of the top floor. At the same time, there's also something about the window to wall ratio that it just models it as one large surface based on the window to wall ratio. So there are a few simplification, but that means that instead of running an energy simulation for 8 hours, we can do it in 5 minutes, for example, on a project like this one here. And then once you have found all of these quantities and then you run your energy simulation, then we have created what we call our catalog of standard components. So instead of when you usually do these kind of like building LCAs, you go in and you define your insulation and you define your final facade material and your interior material, or etc. In this case here, we created a component catalog consisting of generic buildups. And we have taken inspiration from this example library for LCA-based, which is created by Build, which is this Danish institution that also created LCA-based, which is a normal or the normal LCA tool for buildings. So we took inspiration from that and kind of modified it a bit on a few of them, and then created this component catalog. And as you can see here, there are, for example, 7 different types of exterior walls that you can choose from. It's the same with columns. You can choose from various structural systems. You can choose from various slabs, and then you can also choose on more on the roads and infrastructure and landscape. You can choose from 7 different roads and a few different kind of lawn or intensive landscape and stuff like that. So we created a whole catalog. And then this catalog here is then matched with all of the LCA data. So when you click on a timber frame wall, you would get the actual carbon footprint of 1 square meter of that wall, depending on the LCA settings you set in the beginning. And since we are working on these really early stages of urban design, we're really focused on trying to find as much generic data as possible, because we don't want to be very specific around our products. We don't want to choose manufacturers or anything like that. So we're working with generic data from EPDs and from Urban and etc. As I explained earlier. And then once you have defined all of that, then you have your urban carbon assessment where you can do all different kind of various scenarios. And then here in the end, then how can we actually use this carbon data to design urban areas? So maybe you have seen this kind of graph before, but it shows the design stages that a building or an urban area goes through, from kind of like setting the brief to making a concept to make more developed design through. And of course, like the decisions you take really early on is what defines a lot of stuff later on, and it's also what defines the environmental impacts. So the idea of the Urban Decarb tool here is not to be any kind of documentation tool. It's all about being a design tool for urban scale, let's say, estimations. So we're working with these two design stages, as you can see here. So primarily lot 1, lot 2. And you can see an example of what that implies here. So for example, the Fælleby project here in Copenhagen, where we did the master plan on this side here. So lot 1, the brief would be this local plan that they did for the area, and then lot 2 will be where you actually do kind of like the volume massing and set out your roads, and you do your buildings in 3D. And as it stands right now, we actually created 2, not different but similar tools for that, and today I'll focus primarily on the Urban Decarb because it is this 3D software we integrated into Rhino and Grasshopper for architects and urban designers. But I also want to just briefly introduce this other tool that we have created called Plan CO2. So Plan CO2 is a tool that we have created for municipal planners in QGIS, which is this open source GIS software where a lot of local planners are working to do their cards and etc. for local plans. And we got funding by something called Plan 22 Plus, which kind of like supports and helps to create and broaden knowledge and tools around how to work with climate assessments and physical planning in the Danish municipalities. And it's also a focus of Plan 22 Plus that everything is open source, which means that the entire code and tool for this Plan CO2 is going to be fully open source once we release it in a few months after the summer break. And it's something we have developed together with the municipality of Copenhagen and with the municipality of Middelfart. And then when I say us, I mean Henning Larsen and Ramboll. And then we're also supported by Bill to kind of like quality check it. And the way we actually developed this tool is that we took our Urban Decarb tool, which is in Grasshopper, and then we took the entire tool and put it into Excel, which seems like quite a job, and it was also, but it was a requirement by the municipalities that they should also have some kind of Excel database that they can sit and work with to see all of the kind of like formulas behind it. And then once we had this huge Excel sheet, we made it into a Python script, and that's what we then, together with the GIS people in Ramboll, implemented in QGIS, as you can see here. And I think what we're realizing more and more when we kind of like did this code and kind of did this tool here is that maybe Urban Decarb is not necessarily our Grasshopper tool, but instead the code that we have now written into Python in the end, because we want to create this Rhino plugin for architects and urban designers to use it even simpler. Of course, it needs to be written into C# and there needs to be some edits. But essentially, we want to see if we can create this plugin that can then both be put into Rhino, but then also into to QGIS. And why do we want to do that? I think, or not I think, it's because we want to make it as easy as possible to actually perform these urban carbon assessments for the architects and the urban designers, because we want to give them the tools so they can sit and work with it themselves and actually see what changes and what the changes impact in terms of the carbon footprint. So we've been looking into various kind of ways of implementing our actual like 3D Urban Decarb tool, and we have settled on this methodology here, which is called LCA plugin for BIM software. It's quite simple in the way that you have your BIM software, which is in this case Rhino, and then within Rhino, within Grasshopper, we create our LCA plugin. And in this case here, we have a lot of the LCA data externally in kind of like a JSON format where we have all of the EPD data, and then we load that into our Grasshopper plugin for the LCA results to be estimated. And that also means that the actual tool works within the familiar BIM environment for the architects and urban designers. They don't have to open up another software or anything like that. And that also means at the same time that they get this instant feedback when designing, if they can use the Grasshopper tool, which some of them can. And this is kind of like the overall look of how the Grasshopper script works. I will not dig too much into this one. I think I'll show the script instead and how that looks, but it's just to show that there are all different kind of tools and software that goes into creating this tool in Grasshopper. Everything from just using pure Grasshopper scripting to this Ramboll Phoenix tool to Ladybug tools, etc. And then also importing JSON format materials. So here is the actual tool, which I'll just show, and I hope the video is good to see. And so what you do is that you actually, I'll just pause it in the beginning, is that you start by drawing out your entire urban area, and you can create various scenarios for that. And then the first step is that you define all of your structure. That's kind of the first step in the tool. So you define, for example, for some of your buildings, these ones are in timber, and they have a load based on their typology. And then you select some other buildings and then choose concrete instead. And then maybe it's a different typology, so you have a different slab span or different loads. That is all based on the typology. And then you define all of your buildings, as you can see here, and then you start running the actual script. And then what Phoenix does is, as you can see the video here, it runs through every single of the buildings just based on the structure and the typology and the massing, and then generates or estimates this structural system. And it goes quite fast. Of course, the video is kind of slightly sped up, but it takes like 1 minute for it to run these 12 buildings, as I think it is here. And then you can see all of the structure, including also basement. So of course, it's an estimate, but it's quite a nice one compared to what if you usually use per square meter. Then you can change a bunch of LCA parameters, as you can see here. You can change what life cycle phases you want to include, if you want to look at 50 or 60 years, etc. And then you go in and you change or you define all of the typologies for your various buildings. And then afterwards, you can go in and you can first of all see all of your areas for your typologies, and you can also see what population that then estimates would be in this area. And then you can of course override that. Then you can define if there is any basement, and you can also define the windows to wall ratio based on various typologies. Then if you have any transformation, you can define transformation or renovation of existing buildings, and then it will import all of this LCA data here. And then once you have done that, it's time to kind of define all of these various materials here. So what you can do is that you can define a default for all of them, and that will be then assigned to all of the buildings. And then once you have done that, then you can go in and select your various buildings, and then say, I want this, for example, to be timber facade or CLT walls inside the building, and change maybe some of the internal walls. So you can then modify them more specifically if you have selections on some of your materials here. And you can do the same, for example, with the parking one. Yes. And the next step is, so that was all around the buildings. The next step is all of the roads and all of the landscapes. So you go in, and in the same way as before, you select some various different types of roads. And then, for example, if you have a bike path, that's also a different build-up for the road. So you define that, and pavement and paths and etc. So it really helps to have it kind of structured over here in your Rhino file. But these layers are also created when you start the tool in the beginning, so it's easy to put in them. And then you do the same with your landscape. So for example, if you have any trees, if you have shrubs, if you have a lawn, and you can also choose from various types of lawn below the script. Yes. Then the first step it does after defining all of this is that you can run a radiation for all of the PV panels. So in this case, if you implemented solar panels, so it will both include the embodied carbon of the actual solar panel, but it'll then also run what kind of energy this solar panel will produce in the specific site or country or wherever you are, based on also shading. And then you can see the energy production that creates. And then the next step is that it runs this energy simulation. It takes a bit of setting up the whole energy model. And as you will see here in the script, it's also a bit simplified, as I explained earlier, with all of this various windows to wall ratio, and it's all in these boxes instead of having steep roofs if there are any. And then once you have defined all of that, you can run the energy simulation. And again, same as with the structure, I've speeded up for this video here, but it takes less than 5 minutes for an area like this. So it is relatively fast compared to if you run a larger one. Then once you have defined the operational energy, you can go in and you can define whether you have district heating in the area if you're using heat pumps, and then it's multiplied with emission factors that is, in this case, specific for Denmark. And then it gives you a number for the operational carbon for each of the buildings. And then it comes to all of the results. So you can see the results for the buildings per component. You can see it for the complete category, or you can see the total results for the entire area, either per square meter in total or per person. And then the final step of it is that you have these carbon goggles, as we call them, where you can see what are the most emissive parts of your area, what are the less even green if they actually sequester carbon. And of course, that's only one scenario. Then if you want to create multiple and actually compare that, you would have to run this again. Then there is just a brief. So as you can also say, as you could also see in the video, there are some various kind of like design parameters that you can work with. So first of all, you can work with your open spaces and how you define that. If you do a lot of hard surfaces, if you do mixed surfaces, if you do green, you can do the same with parking. If you want to do below ground parking or on ground parking or in separate parking buildings. And then more specifically on kind of like the building size or building scale, you can choose different plot ratios. You can do your massing in various ways. You can make tall buildings or low buildings or wide, etc. And you can work with the structure and the envelope and with PV panels. So there's a bunch of various design parameters that you can work with within the tool. And then here in the end, I'll just briefly talk about a few projects where we have used the tool. So we have used the tool over the last 1.5 years on around 10, 15 internal and external projects. And one of them is the Philippi project, which I talked about before. And actually Philippi is one of the projects where we used the tool after the project was actually designed. It's kind of like our project to showcase how we work with the tool. So I'll give just like a brief intro to how you actually use this. So the first step you do when you use the tool is that you select this location, as that will determine, first of all, your LCA data. And then you define, as you also saw in the video, you define all of your open spaces, you define your parking, your typologies, your materials, if you have basement, and if there is any transmission of existing buildings. And then the next step is that you visualize all of the carbon assessments. So in this case here, you can see that there's a lot of lawn and like more wild kind of like grass area that is not maintained, which means that it is actually sequesters carbon. Then there are, of course, some roads, and then the buildings, depending on how they are shaped and what they're made of, goes from this scale from low carbon footprint to high. So for example, in this case here, 3 of the buildings have parking, half basements, as you would probably say, in concrete. So that means that they will have a higher carbon footprint than at least some of the other buildings around them. And then when you have created one scenario, so that the scenario we just saw was this one over here, but then you also you can do multiple scenarios. In this case here, we said that we want to compare a baseline conventional design of the buildings, so all of the landscape is the same, but we're just changing how the actual buildings the materials of the buildings into more biogenic materials, and then we show a 34% reduction in the urban carbon footprint of all the stuff that is included in the assessment. Then we also did a different project in Aarhus, where we looked at this existing site here, where in opposite to the Philippi project, it's actually a brownfield transformation. So there are some existing buildings, there are some existing landscape, and there are some existing roads and parking. So another use case we found with this tool is that we can actually use it to show some kind of transformation potential of the existing buildings and infrastructure. So that means that in this case here, we actually started by running an analysis to see like how much carbon would it emit if we had to recreate these buildings, in order to give some arguments for saying we should not just demolish the entire area and build new, but instead reuse some of the buildings and some of the infrastructure, as you can see here. And then we move more on to then what the actual tool is made for, this scenario comparison. So then the first scenario would be this more conventional one, where you get rid of the old road network, you do new buildings, you create the buildings, conventional materials, you do a lot of parking below ground, and maybe you reduce some of the landscape. Then we get one number for the carbon footprint. And then you do another scenario with transformation of some of the existing buildings. You maintain some of the infrastructure, and you keep all the landscape, and also do parking above ground. And then that reduces with 11%. And then in the end, you do this final scenario here, where you're then doing all the same stuff as you're doing in transformation scenario, but then also changing the materials to more biogenic materials, and then showing this 34% reduction. So that's how we're using it actively on some of our projects, and here trying to figure out what we can kind of like twist and change in order to showcase some kind of a reduction in the urban carbon footprint. Then here, like final slide, I think it is a bit on our next steps for this tool. So as I said throughout, we're really working on how to implement these supply networks and also the groundworks, because we can see that from these elements here, a lot of the kind of like more on the infrastructure side is probably within these categories here. So we really want to include that in the tool and see how we can work with that and how much that actually takes up of the urban carbon footprint. And the same with mobility. If you can include mobility at the same time as you're creating parking basements, or you're creating a bus station or stuff like that, that's also something we're really interested in seeing how we can implement. And then, as we are a global design studio, we are looking into how we can use this tool in other geographies, maybe of course in the rest of Europe, but then also maybe in the States or Australia, and that requires a different level of data harvesting, as some of these countries do not have like the same level of data as we have here in Denmark and in Europe. And then of course, whenever we have a project or work with clients, they're asking new questions, and we also want to include that, and etc. So we want to continue testing in order to see where and how we should develop this tool. And that was it. So thank you for listening in. Maybe there are some questions.
Thank you, Christian. Not really, actually. So you have done it well. There was only one hand raised in the middle of the talk. So if somebody wants to talk or have a question, just raise hand, and I will invite them in to talk with Christian.
Perfect. That sounds good. Let's see.
I have a question for you, Christian. If others want to use the tool, like, is it possible for them to contact you? And
so the Grasshopper tool is not something we're sharing publicly. That's something we're, at least for now, keeping on our side. The Plant CO2, the GIS tool, and the code is going to be accessible on something called OS2. It's this open source platform for municipalities, and it's going to be accessible during the fall at some point. There's probably going to be some press releases, so then everyone can actually use the tool in this JS 2D version, and also see all of the code behind it in reality, and check it out. So that will be completely open source, but not the Grasshopper tool for now.
Okay. And are you interested in other externals contributing to the tool?
Yeah, I would say always. It seems like a lot of people are kind of like doing maybe not similar tools, but then more detailed on buildings or more detailed on landscape and stuff like that. And we have also been talking a lot with some of the networks like ground systems suppliers. They're creating something called forsynings LCA, how we can like work with them in order to integrate that within our tool. Of course, the open source one, because they don't want to give out to something that is not open source. So yeah, if people are interested in collaborating, we're also interested. Yeah.
I have a question from Sean. I allow him to talk now, then he can ask this question. You're allowed to talk now if you unmute your phone.
Hi there, everyone. Really interesting presentation. I'm work at Ramboll, so I've kind of been following it a little bit in its early stages. But I'd be interested to understand a little bit more about how you modeled and integrated the existing buildings into your kind of scenario testing, because I think that's a kind of really interesting proposition for clients to kind of understand that potential and then be able to, kind of suggest scenarios around that. So if you could tell us a little bit more, that'd be really, really great.
Yeah, I think it depends on the project, because like some of the projects where we didn't have like basically any or not that much data on the existing ones, we kind of used, what do you say, like Google Maps and a bit more like on our own side, trying to figure out what is this facade material, like what is roughly this construction year, stuff like that, in order to estimate. And then we just say that this is what it would require to build a similar building now. So it's not like we're trying to figure out exactly like what EPD they used like in 1950 or something like that. And we also did another project where we actually used also Ramboll's GIS department in harvesting all the data for GIS, where we got a bit more like a detailed look on all of the like facade materials and roof materials. And we could also, that one was a bit more like we had a bit more time for that one. So we also went into drawings to see what is the specific material of this, or like what is the structural system? Is it steel, or what is the spans and stuff like that? So then we kind of like tweaked our tool to get as close to those assumptions as we can see in BBR, or as we can see in those drawings. So in that case, we got a bit closer to saying this is what this specific building would actually require to be rebuilt today. And then it is just, at least trying to show that there is some kind of potential in reusing these buildings instead of just going straight for demolishing.
Fantastic, thank you.
Thanks for the question. Okay, any other questions? Maybe not. No, but then yeah, do you want to say something, David?
No, it's just maybe if there's no more questions, we can round it off now. And
I think so. Thanks for listening in, and I hope it was interesting.
Yeah, thanks for everyone's participation today. And as I said, this is the last one before the summer, but we have a jam-packed schedule in the fall. So check out our LinkedIn page for the latest events. I think we have some building site tours planned and some robotics and other cool things that will be happening. So keep an eye on our LinkedIn page. And if you haven't signed up to follow us, you should do that now. And I wish everybody a great summer. We'll see you guys in the fall.